Here's problem 919. An 80-gram particle moving with an initial speed of 50 meters per second in the positive x direction strikes and sticks to a 60-gram particle moving 50 meters per second in the positive y direction. How much kinetic energy is lost in this collision? So we have mass 1, which is 80 grams, moving with an initial velocity in the x direction of 50 meters per second. It's going to collide with mass 2, which is 60 grams, moving with initial velocity in the y direction of 50 meters per second. This is the way things look like initially, and then after the collision they're going to move together as one with some final velocity. And this final velocity will have x and y components, v final x and v final y. And this is the way things look like finally. Well, we know in the x direction that momentum will be conserved. Mass 1, v1 initial, plus mass 2, v2 initial, will equal mass 1, v1 final, plus mass 2, v2 final in the x direction. In this case, v2 initial will be 0, and v1 final and v2 final will be the same, so we'll have that v final in the x direction will equal mass 1 v1 initial over mass 1 plus mass 2. And that will be equal to 80 grams times 50 meters per second over 80 grams plus 60 grams. So v1 final in the x direction, or v final in the x direction, will equal 80 divided by 140 times 50, which is 28.6 meters per second. The grams cancel out, so that's why we didn't have to convert that to kilograms. Alright, in the y direction, we have mass 1 v1 initial plus mass 2 v2 initial equals mass 1 v1 final plus mass 2 v2 final. And again, v1 initial is going to be 0 because it has no initial velocity in the y direction, and v1 final and v2 final will be the same. So we're going to have that v final in the y direction is going to equal mass 2 v2 initial over mass 1 plus mass 2. So this will be 60 grams times 50 meters per second over 80 grams plus 60 grams. Now 60 over 140 times 50 is 21.43 meters per second. That is our final velocity in the y direction. So we have these two velocities, v final x, which is 28.6, and then v final y, which is 21.43 meters per second. And they comprise our v final. So v final actually is going to be equal to v final x squared plus v final y squared, all this square root, and that's going to be equal to 28.6 squared plus 21.43 squared, all that square root, and that is 35.7 meters per second. That's the final velocity of the combined mass. So we want to find how much kinetic energy was lost. Our initial kinetic energy is 1/2 mass 1 V1 initial squared plus 1/2 mass 2 V2 initial squared. Whatever their speeds are, that's going to be 1/2 times, now we need to use kilograms here, so we have 0.08 kilograms times 50 squared plus 1/2 times 0.06 times 50 squared. And that is 175 joules. That's what we started with. Our final kinetic energy is going to be equal to 1/2, since they're combined, 1/2 mass 1 plus mass 2 times V final squared. That's going to be 1/2 times 0.08 plus 0.06 times this 35.7 squared. And that is 89.2 joules. That's how much we have finally, so we lost the amount we started with minus what we ended up with. So that's going to be 175 minus 89.2, which is 85.8 joules. That's how much energy, kinetic energy, we lost in this collision. 85.8 joules. Answer.